going through 13E and 13F, which means we will have finished the unit. Okay, so that's going to give us 2 revision lessons, Monday and then Thursday, for a test on Friday on chapter 12 and 13. Cool. Let's get into what we're doing today. We're solving exponential equations. Now, we've already done solving exponential equations. We did it by equating the bases, making them the same base, and then we did it using our calculator. Now we're looking specifically at how we can use logarithms to solve these equations. So we have 2 to the x equals 10, and we want to solve for x. Now, a logarithm is a little bit like you can think of it like a square root, okay? It's like a function. Now remember, we can do anything we want as long as we do it to both sides. So we're going to put log on both sides. Here we're going to have log 2 to the x, and here we're going to have log 10. Okay? So we can do anything we want as long as we do it to both sides. So I'm performing the logarithm of 2 to the x, and I'm performing the logarithm of 10. Okay. Now here, one of our rules of logarithms is that we can bring that power out the front. And so we're going to have x log 2 equals log 10. And we're trying to get x by itself. Here, this is x times by log 2. So if we want to get rid of the log 2, we can divide both sides by log 2. That's going to cancel here. We're left with x. X is equal to log 10 divided by log 2. Okay, so I will give you full marks here. This can be simplified a little bit more, okay, because log of 10, okay, log of 10 is log of 10 to the power of 1. Because that's expressed as a base of 10, we can simplify that to be 1 on log 2, okay? So we could simplify it a little bit further. I'll give you 4 marks in the previous step. Now, what we've done there is we have answered it exactly, okay? Because log 2 is going to be an irrational number. It's going to have an infinite number of decimal places. And so when we perform this operation in our calculator in a moment, the solution will have an infinite number of decimal places. So this is what we call exact form. We've answered the question exactly. And if we put it in our calculator, we can round it. We can come up with an approximate solution. So let's do that. 1 divided by log 2. I've got 3.321. I'll round to 3 significant figures, 3.32. That's what we call an approximate solution because we've rounded. Approximate. Okay. Next example is very similar. We're going to log both sides. Move the power down in front. And then divide both sides by log 5. Okay, we remember E is just a number. Now we're not going into natural logarithms here. Okay, so I've sort of said that's a bit of extension. So we're just going to solve this as if we were talking about normal logarithms that we do in year 11. So again, we're going to log both sides. We're going to move the x out the front, log E, and then divide both sides by log E. All right, and so we're answering it in exact form. I think in the textbook it gets you to do a little bit of both. Okay, moving on to the next one. Surely it doesn't say 4 times 3 to the x equals 12. Is that the question? Oh. Let's just change it a tiny bit, just to make it a little bit harder. Let's change that to 20. Okay, let's change that to 20. Otherwise the solution is very apparent. And we can solve by equating the bases. Okay, so if we want to solve this one, guys, before we apply log, we need to get the exponential by itself, which means we just want it to be of the form a to the x on the left-hand side. We just want it to look like that. So that means we need to get rid of this 4 to begin with. So we're going to divide both sides by 4 right at the start. Okay, so we'll have 3 to the x equals 5. All right, that's gotten rid of that product there. Now we're ready to log both sides and rinse and repeat the process we're getting familiar with now. the x out the front, and then divide both sides by log 3. Okay, on to E. We want to solve this problem. We don't have the exponential by itself, so we need to get rid of that product first. We're going to divide both sides by 5. So we'll have 2 to the 0.1x equals 4. Okay, now I'm going to show you the logarithm process, and then we'll look at one way we can equate the bases, equate the powers. So here we're going to log both sides. We'll have log 2 equals log 2 to the 0.1x equals log 4. We're going to move the power out the front. So 0.1 times x times log 2 equals log 4. And I'll do this in a few steps. We'll divide both sides by log 2. So you can see we've got 0.1x equals log 4 on log 2. Now that's 0.1 times x, okay? There's two ways you can think about getting rid of it. You could think, oh, we're just going to divide both sides by 0.1, okay? And yes, that would generate the answer, but it's a bit clunky, all right? I think the best way to think about dividing by 0.1 is multiplying by 10, okay? 10 times 0.1 is going to give you 1, so you're just going to have x there. And then over here we'll times by 10, and so this is just going to become x, and over here we're going to have 10 log 4 on log 2. Okay, and I wouldn't give you full marks there, but we can take that a bit further because this does simplify to an integer. All right, so we're going to use some of the processes we learned yesterday. Log 4, you could write, let's just focus on this part for now. Log 4, you could write as log 2 squared, which you could write as 2 log 2. Okay, you can bring that power up front. So log 4 is equal to 2 log 2. And so that means we could replace this statement in here, log 4, with 10 times 2 log 2 on log 2. Okay, that's going to be 20 log 2 on log 2. And the log 2 is at the top and the bottom, it can cancel. And so the integer that it simplifies to is 20. All right. Okay, let's look at the other way we can solve that by, let's go right back to this step here. We have 2 to the 0.1x equals 4. So this is a bit of a refresher of what we've done already. Now 4 we can write as 2 squared. They have the same base, therefore we can equate the powers. Therefore 0.1x equals 2. We want to get x by itself, so we're going to multiply both sides by 10, and we'll get x is 20. Okay, so that seemed like a much more efficient way, but that's only when we can express the bases with the same power. Over here, you can't do it. Those bases do not have a similar power, a similar rational power. Okay, so it's only circumstances, and specifically in the test, it will say solve by equating the bases, so to be very clear, or it will say solve by using logarithms. Okay, so that's how we use logarithms. Let's get into exercise 13e, and then we'll come back and look at 13f. All right, yep, stop this one.